Alright, in this section here we will be working some problems, polynomial and rational inequalities, and we'll be finding their solution sets and writing them in interval notation. So let's move on over to the whiteboard and get started. Alright, let's start off with, of course, we always start off with something easy. And here we'll give this one a number here. So let's start off with x squared is less than 10 minus 3x. That should be an M right there. It's not dot, I think there is a .co now. It's .com. Okay, I need to fix that. What we'll want to do here is get this thing in standard form, and let me just shift to the left. Let's go ahead and take this 3x over to the left so it becomes a positive 3x. And let's take the 10 over. Minus 10 is less than 0. So we factored some quadratics in some earlier sections and found the solutions to the equations. And basically that's what we're going to do here, except we're going to add a few more steps. Okay, so let's go ahead and factor this. This is a pretty easy one here. We'll set it up like this at first. Alright, go ahead and rewrite that part. Okay, so two numbers multiplied together gives us negative 10, and when we add them, we get 3. So what about 5 and 2, right? We know that 2 times 5 is 10, and we know that 5 minus 2 is positive 3. So let's put a plus sign here and a minus sign right here. Okay, so as you can see here, if the zeros of this guy are going to be negative 5 and 2, right? Because when I plug negative 5 in, I get 0, and when I plug 2 in, I get 0 also. Alright. What we're going to do now is we're going to draw a graph. Now, of course, this is just a one-dimensional graph. Right. And we're going to go ahead and label our zeros. We call these our zeros here, and we will label them on the graph. Alright, so let's put negative 5 right here, and we'll put 2 right here. Okay, so the next thing what we'll want to do is we're going to do what are called some test points here, and I don't know, we use a different color for test points. How's that? So pick a number to the left of negative 5, and how about negative 6? That's a good one. And then we'll pick 0 here, and always pick 0 if you can. And then we'll pick a 3 here because it's easy to plug 0 in and find out if it's negative or positive. And so that's what we're going to be doing now. Okay. So what we're going to do here is we're going to plug in negative 6, and let's see, how do I want to do this? Negative 6. We'll draw an arrow here. What we're going to do is plug in negative 6 into this. So negative 6 plus 5 is a negative number. Okay, negative 6 minus 2 is a negative number, and a negative times a negative is a positive. Alright, negative times a negative is a positive, so we're going to put a positive sign right there. Right, and then what we'll do is 0, plug 0 in, so 0 plus 5 is 5, 0 minus 2 is negative 2, and a positive times a negative is negative. Right, we'll put a negative sign there, and then we'll plug in 3. Alright, so 3 plus 5 is a positive number, 3 minus 2 is a positive, and a positive times a positive is positive. Alright, put the positive sign here. Okay, so this inequality here is this, whatever this is, it must be less than 0. So in other words, what's less than 0? Well, it's just all negative numbers. All the negative numbers are the ones that are less than 0. Okay? And we do include, we can't include, I should say we can't. And we don't include negative 5, so we're going to put a parentheses around this. And then we'll put a parentheses around that right there, between negative 5 and 2. So we can use all the numbers between negative 5 and 2, but we can't include negative 5 and 2 because this inequality doesn't have the equal sign under it. You see that? And so we'll write that interval, and I didn't really mean to do it in red. I got so many colors going on here. Alright, so we're going to write that interval between negative 5 and 2. Okay? Between negative 5 and 2. Now this is interval notation. If we wanted to write the inequality notation, we would say x is greater than negative 5 and x is less than 2. X is less than 2. Okay? Alright, well let's take a look at another one. That was pretty easy, I guess. It is compared to what we're going to be doing here in a minute. Yeah, don't mean to scare you. Alright, so let's go with, this is 2 here. Alright, so we'll go with x squared plus x is less than 12. Less than 12. So we want to get this in standard form. So we're going to write x squared plus x minus 12. Bring that 12 over to the left-hand side and set it equal to 0. Now we'll want to factor this. Of course, that's one of the techniques for finding the zeros. And since we're learning this for the first time, let's say, we're going to do some easy ones where we can just factor them. Okay, so two numbers multiplied together gives us 12, and when we add them, we get a positive 1 here. And that looks like probably 3 and 4. Right, and this is going to be a minus, and this will be a plus. Forgot to write an x here. Okay, so the real zeros, we could write real zeros here. The real zeros are going to be 3 and negative 4. Right, that's what makes this 0, and that's what makes this 0. Okay, and then what we'll do now is let's draw a graph. Alright, let's label our zeros on the graph. So we have negative 4 and 3. Okay, and now what we'll do is our test points, and our test points were in orange, so we want to probably stick with that same color scheme. And of course I used green for the number line. Wow. Okay, let's try something different here. How about green this time? Okay, so our test points are going to be negative 5, 0, and we'll use 4. Alright. Okay. Okay. So let's look at negative 5. Negative 5. When we plug negative 5 in up here, we get a negative number, right? Negative 8. Plug negative 5, we get a negative number, and a negative times a negative is a positive number, so we're going to put a positive sign right above that. And then take a look at 0 here. So take 0, plug it in, you get a negative. Take 0, plug it in, you get a positive. 0 plus 4 is 4, right? And you got a negative times a positive, and that's going to be negative. And we need to write that above there. And let's do one more, 4. So plug 4 minus 3 is 1, and 4 plus 4 is 8. And so we get a positive times a positive, and that is positive. Okay. So this sign right here, right, this number's got to be less than 0, which means it has to be a negative number. Okay, it has to be a negative number. So that means that we're going to be looking at just this interval right here. Right, just this interval right here. Now we can't use -4 and we can't use 3, because if we use -4, right, we end up getting 0 here, and 0 times a number is 0, and 0 can't be less than 0. So you can't have 0 less than 0, so we can't use -4. Alright, so we'll go ahead and write this interval notation. Our solution set is between -4 and 3. Right. And that's interval notation. Our inequality notation would be x is less than -4 and x is x is greater than -4 and x is less than 3. Less than 3 there. All right. Okay, we are moving right along. So let's take a look here at number 3. All right. So we have x squared plus 21 is greater than 10x. So we want to get this in standard form, and that's going to be x squared minus 10x plus 21 is greater than 0. Okay, so let's go ahead and factor this. Alright, so what about 7 and 3? And since this is a minus sign right here, wait a minute. Yep, that'll have to be minus and minus, because -7 times -3 is a positive 21, and when we add them we get -10. Okay, so the real zeros in this one are going to be 7 and 3, because when I plug 7 in I get 0 here. When I plug 3 in I get 0. Okay. Alright, let's now draw a graph. I guess we'll go back to, boy, that's not exactly a straight line. Not exactly. So let's go ahead and label 3 here and 7 here. How's that? Okay. Alright. So our test points will be 0 and what's another test point? 4. I guess 4 is a test point. And then we'll use 8. 8 as a test point. Okay. So we take our test points and we plug them in up here to determine if it's going to be positive or negative. And you know what? We'll skip that step there. So let's plug 0 in. So we get a negative. Plug 0 in. 0 minus 3, you get a -3. So you get a negative times a negative, and that's going to make that a positive. Take 4, plug it in. 4 minus 7, that'll be a negative number. 4 minus 3, that's a positive, and a negative times a positive is negative. Now let's take 8. 8 minus 7 is a positive. 8 minus 3 is a positive, so that's going to be a positive. Okay. Now you can pick any number you want to the right of 7. I just picked 8. You can pick 9, 10, 11, 12. It doesn't matter. You could pick a fraction. You could pick an irrational. Whatever you want to do, right? But pick something that's easy, like 0 is easy, right? Okay, so we got that. Now let's take a look at our inequality here. Now this number must be greater than 0. In other words, it's a positive number, positive integer, right? It must be greater than 0. Okay, it's got to be a positive. So we're looking at everything to the left of 3, but it can't include 3, because remember, if we include 3, we get 0 here, and 0 times a number is 0, and 0 can't be greater than 0, so we can't use 3. Right? But we can use anything to the left of 3 on the number line, and that means all the way out to negative infinity. Well, I mean, we can't use negative infinity, but you get the picture, right? Use it in parentheses here because we can't use 3. All right. Union. Okay, the symbol right here, union, means we're just joining both of these intervals, and now we're going to go from 7 to positive infinity. Okay, to positive infinity, right? So we'd end up setting this up as two separate inequalities, where x is greater than negative infinity, less than 3, and then we would write the other inequality as x is greater than 7 and less than infinity, and I'll leave that to you. Okay, so this is pretty easy. We're finding the solutions to this inequality up here. All right.